Here's a lesson on inverse of functions. And before I get started with this, you need to know one other thing, and it's called one-to-one functions. A function doesn't have an inverse unless it's a one-to-one function. And what a one-to-one function is it means for every x value, there's exactly one f of x value. And the easiest way to see this is, does the function pass the horizontal line test? And you might be saying, wait a second, don't you mean the vertical line test? And the answer is no. The horizontal line test, if you take a look at a parabola, I'm going to do some red. Take a look at a parabola. The parabola looks something like this. And if you draw a horizontal line, you can see that the parabola passes through, the horizontal line passes through in two spots, which means it is not one-to-one. However, if you had a cubic function, like y equals x cubed, and that's not exactly the best, y equals x cubed, this actually is one-to-one because it only passes through the vertical horizontal line at one spot always. So this y equals x cubed has an inverse, but y equals x squared, the parabola, does not. I'm going to give you a very, very easy example, and I'm going to do something like this. I'm going to say, let's see, here's a function. It's a linear function, and the slope is up 1 over 2, so it's going to be y equals 1/2 x plus 1. Now I'm going to show you how to find the inverse of a function. And I'm going to also show you something else that's kind of neat. The first thing I like to do is, if it's written in y equals form, I change it to f of x equals, oh, that's not true. The first thing I do, is swap x and y. And so now I'm going to say x equals 1/2 y plus 1. That's step 1. Step 2, get y by itself. And I'm going to subtract 1. I get x minus 1 equals 1/2 y. I'm going to multiply by 2. And I get y equals, that's going to become 2x minus 2. Something interesting happens here. I'm going to do this in blue. And 2, I go up 2 over 1, up 2 over 1, and this is a pretty awful graph, but this is f of x equals 1/2 x plus 1, and this is, I'll write it in a second. Step 3, replace y with f inverse of x. And so when I do that, I get f inverse of x equals 2x plus 2. And what I want you to notice, and if you use graph paper, you'll see this much clearer, is that these, the function and its inverse, are actually reflections of each other over the line y equals x. So if you have a graphing calculator and you think you've done this right, plug in both functions and then type in y equals x and see if they are symmetric. If they are, then you're in great shape. This is really all you have to do in order to check it out. It is possible to do, whoa, my son's in his Halloween costume, he looks awesome. It is possible to do inverses with functions that are not one-to-one if you restrict their domains. Alright, so I'm going to do one last question, and it's going to look something like this. F of x equals 3 over x plus 4. So I'm going to say y equals 3 over x plus 4. I swap my x and y and get y equals, that's not true, x equals 3 over y plus 4. I'm actually going to cross multiply here, and I get xy plus 4x equals 3. Nice. I subtract my 4x. Oops. I subtract my 4x, and now I'm left with xy equals 3 minus 4x. I'm going to divide by y. I'm going to divide by x, and I get my final answer of, I'll write this in black, y equals 3 minus 4x over x, and now I write it as my inverse, 3 minus 4x all over x. There is one last thing I should have mentioned before. I forgot. I just did a video on composition of functions. If you do f of f inverse of x, it should equal f inverse of f of x, which will always equal x, and that's a huge that's a huge piece of information. All right, I'm getting a little distracted, so I'm gonna end this video, and that's it.